Hello. Okay, thanks for coming. Welcome to the second section in the developer track. I'm very excited to announce Anupama and Neil from Ooyala, who are going to tell us about testing Spark.
Good afternoon, everyone. I'm Anupama Shetty, and this is Neil Marshall, and we are from Ooyala's analytics team. We both work as software development engineers in test, that is SDET. And today we are here to talk about testing Spark and to share some of the best practices that we can follow while achieving a good quality for your Spark application. And here's our agenda for today. We will start with a brief overview of our application, and then move on to explaining the details of environment setup for testing, and then share some of the best practices for testing. Then Neil will be talking about performance testing for Spark applications, and he will also share some of the best practices that you can follow while doing that. And here's a quick overview of our company. Ooyala was founded in 2007. We have 300 plus employees across the world. We have different products ranging from video-based analytics to monetization products and services. And here's our overview of our application. We have basically an analytics ETL pipeline. So at the bottom in the diagram, you can see it starts with a player. So Ooyala has its own video player, which we use to serve videos for our users across the world. So every action conducted by the user, whether it's playing a video, stopping a video, or resuming a video, generates a corresponding event which gets logged by our backend player log collector, which further on passes it to a message queue, which is Kafka running along with Zookeeper. And from that point onwards, that data acts as the input for our Spark application, which is the Spark log processor. This is the application where most of the heavy lifting happens. So we use each of this incoming data and we calculate different metrics such as video conversion rate, player conversion rate, and engagement metrics. So this is the Spark application, and this is where we use Spark. And once processed, we write the data out to HDFS, which is the Hadoop file system. So this is a brief overview of our application, and now I'll talk about how we test this whole pipeline. Before that, I'll add some more details about the Spark-based application. So our Spark log processor can process two types of data, JSON and Thrift, and it runs in two modes, which is batch and streaming. Streaming is the mode that we have running 24/7, and we have continuous data coming in, which we process, calculate metrics, and write to our HDFS. For this, we use the Spark streaming context. And we also have batch mode, which we use on a need basis, where we have the input data in a text format, which we push into the log processor and write the data to HDFS. And here we are moving on to how we test this application. So I know many of us are building Spark applications. While it's important to have robustness and scalability, we also need to ensure that it's of good quality. So we have a test setup to test the entire pipeline, and we have a test script that brings up each of these components in local mode. So as I explained, our pipeline starts with the playing of a video. So I use a Ruby-based gem, which is derived from Selenium, called Water, to launch browser and simulate player actions, such as playing a video, resuming, or pausing a video. And that in turn pushes the events to the player log collector component that is running locally on our host test machine. And further on, it pushes it to Kafka, which we have simulated by using a local virtual machine, where we have deployed both Kafka and Zookeeper and have it running. I will show more details on how we achieve that using a virtual machine. And once it goes through Kafka, it pushes it to the Spark log processor, which we again have it in local mode running on the host test machine. And once it is processed, it writes to HDFS. It can either be a local directory for testing purpose, or it can be a HDFS setup specifically for testing in a testing environment. So this is how we are achieving an end-to-end integration testing setup to test our pipeline. And now that we know how we test at the high level, I'm moving on more to the unit test level. So as you know, The main component that uses Spark in our pipeline is Spark log processor. And to achieve unit testing of a Spark application, we need to take care of a few basic setup. Luckily, Spark comes with a bunch of pre-configured environment variables. Once you set it to point to your application, it's very easy to get going in terms of unit testing. So the first one is you need to package your Spark application, and it's very easy to do using an SPT assembly. Once you have the package jar, you have to point spark.jar to your application. So now Spark knows which application to run. Next is you have to point to the Spark cluster. It's very easy to achieve by using spark.master to local. What this means is you're running Spark application in local mode using a single worker thread. If you want to test it with parallelism, you can also launch multiple worker threads in local mode by specifying local with a bracket the number of threads that you want to launch. And the last configuration you need to do is you need to point your Spark code, and here it's done using a variable called Spark directory, which basically points to the packaged Spark jar. Once you have this set up, you have everything that's required to create a Spark context. And in the last line, you can see all these setup variables are used to create a Spark context. And here you have a little more code. For Scala, you have a very good test framework called Scala Test, which provides a lot of flexibility in terms of performing different kinds of testing, whether it is BDD or using mocks. And here I'm showing the before and after block, which is similar to a setup and tear down, which you use in most of the test frameworks. And because sometimes the Spark port ends up conflicting, you want to make sure you create a single Spark context in your before block and continue using the same Spark context in all of your test blocks. That happens between your before and after blocks. And it is as simple as this. You create a Spark context, and then you can pass it to your Spark application and test the different functions that you apply to your application. And here are the details about how I'm achieving a local virtual machine and configuring its ports. So we have a service called Vagrant. The way you configure Vagrant is using something called a Vagrant File. And here in the screenshot, you can see how we have mapped a local port to the virtual machine port. For example, Zookeeper runs on 2181, so I've mapped the local 2181 port to your virtual machine 2181 port. So when I have the whole end-to-end integration pipeline running, my player log collector pushes data to a local 2181, which is mapped to the virtual machine, which again the data is pulled by your Spark log processor. And at the bottom, you can see some of the configuration, which you will know if you have been using Kafka. It's very easy to configure a topic or a group and get going with Kafka. And here is some more details on how you can connect a Kafka stream to your streaming context. So till now, you saw how you can do how you can achieve unit testing for a simple Spark context. Now I'm showing how you can do it for a streaming context as well. You have a basic 4 steps here. The first one, you create a Spark context, similar to the one you saw earlier. Next is you create a streaming context for which you pass the earlier created Spark context. So now you have these 2 ready, and the third one is you have to set up your continuous stream. In my case, it is a Kafka stream, so I'm using the Kafka utils that comes with your Spark code, and then I'm configuring it to localhost. That's where my Zookeeper is running. And once you have these 3 things ready, now all you want to do is you want to connect this Kafka stream to your streaming context so that your streaming context knows where to expect the data from. And that is what I've done, and now you have your Spark streaming context code ready and ready for your unit testing. And now I'll share some of the best practices. So tracking code coverage has been very useful in knowing where you stand in terms of maintaining a good quality for your project. We use 2 tools, S-Coverage and SECT. Both have been great. S-Coverage is very good for Scala because it provides expression-based coverage, so so it applies very well for Scala code. And you have different configuration settings, which makes it very flexible. If you have a lot of benchmark or utilities-based code, you can very easily exclude it from your coverage so that you get the numbers that you care the most about. And and it's very easy to have it running on Jenkins to view coverage reports. So we highly recommend tracking your code coverage. And another thing is we use GitHub to track our code repositories, and many a times there are many developers working on multiple features, and they end up creating pull requests at the same time. You want to make sure that each of these pull requests is clean and did not break any of the tests before merging it to your master. So one easy way to do it is connect your GitHub to your Jenkins, and every time anyone creates a new pull request, a corresponding test job gets triggered on Jenkins. And the results of this test job gets posted back on pull request. So it's very easy for you to see whether this pull request is ready to be merged. And to make it even better, in case a test failed, it's very easy to trigger a rerun by just giving simple commands like retest directly on pull request. So this triggers a second run and posts the results again. So this saves a lot of time, and it avoids a lot of manual tracking or monitoring of pull request. So these are some of the best practices that we highly recommend you use. And now I'll hand it over to Neil, who'll be talking about performance testing. Thank you.
Hello, my name is Neil. I'm also an estet at Ooyala. I'm deaf, and if you're wondering how I'm communicating with you, I do have two interpreters with me today, Nunu and Beth. So I'm going to be focusing on performance testing. So let's get into my first slide. So admittedly, I extracted these 3 points from Wikipedia. So what is performance testing? It's a practice striving to build performance into the implementation, design, and architecture of a system. It determines how a system performs in terms of responsiveness and stability under a particular workload. And it can also serve to investigate, measure, validate, and verify other quality attributes of a system, such as scalability, reliability, and resource usage. So what's Gatling? It's a stress test tool. Don't worry, it's not actually a Gatling gun. It is not dangerous in any way. It's just a tool. So there are a lot of different performance test tools. Why should we pick a Gatling? So Gatling has powerful scripting using Scala. It also has Akka and Netty, which is Netty is great for I/O asynchronicity. You're able to run multiple scenarios in one simulation, and scenarios equals code plus DSL, and also in the end you get graphical reports with clear and concise graphs. So how does Gatling work with Spark? There are two different ways of accessing and passing on information to Spark. One is through the web services, and the other is through the web app. Either of them can be used to pass requests to Spark, and then pass the response from Spark back to Gatling, as you can see here. For this particular example, Gatling is going to be running against a Spark job server to do a word count. That's going to allow us to start developing a test app. This will be a simple example of a way that you can use this in the real world, and then you can expand upon this for more complex applications for your own particular situations. So what is a Spark job server? So it provides a RESTful interface for submitting and managing Apache Spark jobs, jars, and contexts. It's also in Scala 2.10 plus CDH5 Hadoop 2.2 and Spark 0.9.0. And if you want any more information about the Spark job server, I highly recommend Evan Chan and Kevin Chu's Spark query service presentation, which is later on tonight, which I think is at 4:45. So here are the simple steps that we need to take to set up and run a Spark job server. First, you can just clone the Spark job server from GitHub using this git command. Then install SBT if you haven't already, and type SBT in the Spark job server repo. And then from the SBT shell, simply type restart. So in our example, these are the steps that you would follow to package and upload a jar to the job server. So you're going to package the test jar of the word count example using this command that I have here, and then upload. And remember that the example that we have here, the test is called test is the app name. So run a request against the job server. It's important to note that the string of words from the curl command line, what we have here. The request posts the string of words to the job server. The job server then aggregates total counts of the words, so you'll then see it's going to aggregate all the words and start counting how many A's we have, how many B's we have, so on and so forth. So as we can see here, there's 2 A's and 2 B's. And this is the same way that Spark aggregates the results. As I mentioned in the previous slide, the app name is test, and after the jar upload to test. So look at the class path of the word count example class. I'm going to show you the source code for this in the next slide. So here's the source code, and the source code is already included in the Spark job server on GitHub. So remember, the request command includes the word count example class from the test class path. So the job server receives the request, and the class path will point to the process of the run job function to that particular string. So you can see the data aggregation results here. The validate function will detect an empty string, and it will throw a noInput.string config param in JSON format. This is how the class extended the Spark job interface for a job process. Again, if you want more information on how this is implemented or how to implement a Spark job, please attend the Spark Query Service workshop that goes further on this topic. So now we have the Spark job server up and running. The jar is uploaded and everything's done and ready. The next step is to write a basic Gatling script for the word count example. So there are two key things. Scenarios define the steps and actions that Gatling will do to the job server. On line 3, this names the performance test as post a word string. Localhost 8090 is included in the HTTP protocol method. That's already there. The next line includes the whole API URI after port 8090. And I showed that in the slide before with the curl command. In the next line, the body method contains the word string. The body is the exact wording that you saw in the few slides back. And the command post will post a string to the job server. The last line checks the status 200 after the response, and status 200 means everything's okay. And finally, the second line shows the number of time that we want to repeat this. So now script Gatling for the word count example. Setup puts users and scenarios as workflows, plus assertions together in a performance test simulation. So in this example, we inject 10 users in 10 seconds into scenarios in 2 cycles. And we're ensuring a success rate of greater than 80%. And you can see that in the code on the bottom of the slide. So after that's run, we get the results and they look like this. And it's not really pretty, it's only in text. But at the bottom of the results, there is a URL that you can point your browser to, and that will give you a better graphical representation of your data. So you'll notice 2 indicators here. So for 10 users, we ran the test 2 times. That's a total of 20 trials. All of our trials did pass. And the green bar shows passing. We would have had a red bar had any of them not passed, but we didn't have any. And this scenario said post a word string, 20 passes, 0 failures. And the graph shows response time in milliseconds. We had a minimum of 80 milliseconds and a max of 140. So these are just a few of several charts that they provide you. This one here, the label has word count test. First, it represents how many sessions are being run. We had 10 users in 10 seconds, and we want to see how many sessions the job server can handle. So this graph represents the first 7 seconds in one session. This is 7 seconds. And there was just one session. When we went from 7 to 8, we had one more session added. And then when we went to 9, we lost that session. And the orange line means active sessions over time. So now for my last slide, best practices on performance tests. You're going to run performance tests in Jenkins and set up baselines for any performance tests with different scenarios and users. So during your daily Jenkins runs, you want to keep track of your logs. If you experience any failure, you can refer to those logs. Maybe the threshold has been exceeded or resources have been maxed out. Most importantly, you have to set your expectations. You should run large tests of, say, 1,000 users, see if there's a failure. And then run a binary search-like test till you reach the point where the maximum threshold has been reached. For example, if tests pass at 500 users, then you can set up 500 users as your baseline. It's really important to document all hardware and Spark settings, such as how much RAM, how many nodes, and how many nodes you have for each test. Then you can tweak that as needed to make improvements for your speed. Okay, so any questions? And you can ask Anupama or I, if we have time.